This is another example of a mass-volume mixed stoichiometry problem where a gas is either required or emitted at STP. The question is, how many liters of oxygen are required during the burning of 42 grams of rubbing alcohol, also known as isopropyl alcohol or isopropanol? The molar mass is given, and as is the formula, the chemical formula of rubbing alcohol, but what is not given is the equation. But our clue is that it's burning, and burning means that it's a combustion reaction, and it's a carbon-based compound that's going to be doing the burning. And we know that carbon-based compounds require oxygen to burn completely, and during that combustion process, carbon dioxide and water are created. So the skeleton equation is C3H8O plus oxygen gas burns to produce carbon dioxide gas and H2O, water vapor. According to the Cho rule, I need to balance out my carbons first. I have 3 on the left, so I need 3 on the right. Second in the Cho rule is hydrogen. Hydrogen, there are 8 on the left. I need 8 on the right. In order to get my 2 up to an 8, I need to multiply this entire thing by 4. Because I know I can't change that 2 in the H2O. Or else it wouldn't be water anymore. Now that I have my carbons and hydrogens balanced, I need to check with my oxygens. I have a total of, if you were to count them, 10 oxygens on the right, which means I need 10 on the left. And the easy way to do this is I need 10 on the left, but I've got 1 oxygen kind of given to me as free, and I don't want to mess that up if I can help it. So if I have 10 oxygens on the right and I need 10 on the left, I'm going to understand that I have 1 given, so I need to actually get 9 oxygens from this O2. And the only way to get 9 oxygens from O2 is to have 4.5, because 4.5 times 2 is 9. But we know that a proper balanced equation cannot use a fraction or a decimal as a molar coefficient. So I'm going to remember to double everything. If I double everything, I get a 2. That 4.5 becomes an actual 9. And then everything else is affected too. This 3 becomes a 6. This 4 becomes an 8. And I no longer have 10 oxygens, I actually have 20 oxygens. And that should match up with the fact that I have 20 over here now also. I have 18 plus 2. And overall, our equation is now balanced. And that's all that matters, is getting the equation balanced. I'm going to erase this extra stuff so it's not too busy. And we have our balanced equation for the combustion of isopropyl alcohol or isopropanol rubbing alcohol. And we're going to start off with our general thing, which is what we know. And we know you have 42.0 grams of C3H8O over 1. I need to turn those grams into moles. Remember to be specific with what is actually being converted or moved at the time. The molar mass is given to you to save you some time. 1 mole of isopropyl alcohol has a mass of 60.1. And once we have moles of that, we're going to go from moles of isopropyl alcohol to our target. And this is where you have to stop and ask yourself, what exactly are we going toward? We're asked for liters of oxygen. So we don't care in this question, we do not care about water. We don't care about carbon dioxide. We want to know how much oxygen was required during the burning of this much rubbing alcohol. So we look at the balanced equation's molar coefficients, and there's a big old 9 next to oxygen, and the big 2 next to the rubbing alcohol. Had you not doubled the molar coefficients, and you left it as a 1, a 4.5, a 3, and a 4 as far as in front of all the compounds, you would technically get the right answer, but that's not how proper equations are balanced. But it would work mathematically. From here, I know that I don't want moles of oxygen gas. This oxygen gas was present at STP, so I know that moles, 1 mole of a gas at STP is 22.4 liters. Before I do any math, I want to verify that grams have turned into moles for the starting compound. Moles of the starting compound are related to moles of the compound of interest, or the molecule, or the substance of interest, which is oxygen. And then moles of oxygen were turned into liters because that's what it's asked for. Remember that you may not even see the word mole in the equation. You may have to go through the mole. Now, the mole is the most important thing to go through because it relates quantities. The math for this would be the entire numerator divided by the entire denominator, and if you do that correctly, your answer with sig figs is 70.4 liters of O2 gas. Liters of oxygen. That's how much oxygen is going to be consumed if this mass of rubbing alcohol is burned. It's important to note that occasionally you may not see the mass of a liquid. Isopropanol is a liquid that will have vapors above it that will do the burning. Sometimes you will see the density of something, which of course is grams per milliliter, or grams per cubic centimeter. So the density of a liquid may be given, and you may be given the volume. And you know that if you're given density equals mass over volume, you may be given the density, and you may be given the volume, and you have to find the mass. And here we're given the mass, but if they had given us the density and the volume, we could have calculated the mass. So just make sure that you're going along with what's given and getting to, at minimum, you got to get to grams, and then turn those grams into moles using the molar mass, and then move along to get to your target. And be very careful that your target is, your upper right unit is the target. It asks for liters of oxygen. This could have asked for milliliters of oxygen, in which case we would have turned our liters into milliliters by multiplying by 1,000. So just make sure that you're moving along in a logical manner, and you will get the question correct.